Welcome viewers, in this video we will see the details about the Millman's theorem. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. Millman's theorem, one of the theorem available in the circuit theory. So this theorem enables a number of voltage or current sources to be replaced by single voltage source or single current source. So the main objective of the Millman's theorem is with n number of voltage or current sources can be replaced by a single voltage source or single current source. Now we'll see the statement first for the voltage source by referring the voltage source. Then we'll go to the current source. In any network, if the voltages V1, V2 up to Vn with internal impedance Z1, Z2 up to Zn respectively are in parallel, then these sources may be replaced by a single voltage source with V in series with the impedance Z. Refer this diagram. So we have voltage sources V1, V2, Vn, right? N number of voltage sources available. In each source we have the impedance Z1, Z2 up to Zn, right? So the voltage sources are connected in parallel that can be replaced by a single voltage source with a single impedance. V is a single voltage source V with a single impedance Z. This is a terminal AB. Terminal AB we have n number of voltage source connected in series with the impedance that is replaced by single voltage source and impedance. Now we see how to calculate this, the value of V and Z, voltage and impedance. So the voltage V is nothing but V1 into Y1, right? So this Z1 is available, impedance. Y1 is nothing but admittance. 1 divided by Z1 is nothing but the admittance. So V1 into Y1 plus V2 Y2 plus up to Vn Yn divided by the sum of admittance Y1 plus Y2 up to Yn. So by using this formula we can calculate the voltage, resultant voltage V. Similarly the impedance Z equal to 1 divided by Y1 Y2 up to Yn, right? So the n number of voltage sources connected in parallel replaced by single voltage source with impedance. The single voltage source V is calculated from this formula. Impedance is calculated from this formula. Y is nothing but admittance. So in general we can write it as V equal to sum of V into Y divided by sum of Y. Voltage into admittance divided by sum of admittance. The Z is nothing but 1 divided by sum of admittance. So in the given circuit converting each voltage source into equivalent current source. Now we'll see the proof for that, how we are getting this formula. So this first we'll consider the voltage source, that is now we are going to convert into current source. Now we'll see the diagram, how we are converting from voltage source to current source. Now refer this diagram, we have the current source available in parallel with impedance is connected. This is the first current source, second current source and third current source. Now that is converted into current source in series with parallel with the admittance Y1, I1, Y1. Similarly I2, Y2, I3, Y3, right? So the current source now converted into the current source with the admittance. Now we'll see the formula for that. I1 equal to V1 by Z1. So this 1 divided by Z1 is nothing but Y1. Admittance and impedance both are reciprocal, right? Impedance means opposing the current, property opposing the current. Admittance means allowing the current. So that 1 divided by Z1 is Y1. Similarly I2 equal to V2 by Z2, that is V2 into Y2, admittance. Similarly I3 equal to V3 by Z3, that is equal to V3 into Y3. Right? So this Y1 is nothing but 1 divided by Z1. Y2 is 1 divided by Z2. Y3 is 1 divided by Z3. Right? So this circuit refers impedance. This circuit refers the admittance. Current source in parallel with the impedance. Here current source in parallel with the admittance. Now we'll go for the further analysis. So now the current source are in parallel we can obtain single current source. Single current source equivalent to the combination. Let I be the current and Y be the admittance of the equivalent current source. So that I equal to I1 plus I2 plus I3. So the admittance Y equal to Y1 plus Y2 plus Y3. So by using that we can draw this diagram. Only one current source in parallel with the admittance. How to calculate this V? V equal to I by Y. That is I by Y1 plus Y2 plus Y3. I also I1 plus I2 plus I3. Right? So that V equal to I by Y, that is sum of currents divided by sum of impedance. Right? So this one can be converted into voltage source also. The same thing can be converted into voltage. Converting the above into equivalent voltage source. Voltage source means impedance is connected in series with the voltage source. Current source means connected in parallel. Voltage source means current connected in series. So we have V and Z. How will you calculate this Z? V is already calculated. V equal to I by Y. So this is the formula. Right? I1, I2, I3 divided. This I1 is nothing but V1, Y1, V2, Y2. So V can be calculated. How to calculate Z is 1 by Y. That is 1 divided by Y1 plus Y2 plus Y3. Right? So current source with admittance available. By using that we can convert voltage source into impedance. The voltage is calculated in terms of the sum of voltage and admittance divided by sum of admittance. This impedance is calculated 1 divided by sum of admittance. This admittance value available here. Now we'll go to the current source. This is depends upon the voltage source. Now we'll go to current source. Now consider this current sources. There are 3 current sources connected in series with 3 impedance. Consider 3 current sources of I1, I2 and I3 having internal impedance of Z1, Z2, Z3 connected in series. Our aim is to replace by a single current source, single source. These 3 current sources with internal impedance can be replaced by a single source. That is our aim. So the step 1 is convert each current source into equivalent voltage source. Into equivalent voltage source. So V1 is connected in series with the Z1. Current source means it is connected in parallel. Voltage source means it is connected in series. V1 Z1, V2 Z2, V3 Z3. This terminal A and B. Right? Now the current source, 3 current source with internal impedance are converted into voltage source with internal impedance. These are all connected in series. Current source means it is connected in parallel. Since all 3 voltage sources are series, replace them by a single voltage source and single impedance Z. How to calculate? V equal to V1 plus V2 plus V3. All are connected in series. Similarly, impedance also connected in series. Z equal to Z1 plus Z2 plus Z3. So that we can replace with a single voltage source and single impedance V and Z. Right. Now we'll see the equivalent current source. Again, how to convert into equivalent current source. So this is the current source is available, I and Z. Right? How to calculate I, V by Z? V is nothing but V1 plus V2 plus V3. Z is nothing but Z1 plus Z2 plus Z3. That just now we calculated. So I equal to this again. V1 is nothing but I1 into Z1. I2 Z2. I3 Z3. So that Z1 Z2 Z3. Right. So from that, how will you calculate Y? The admittance is 1 by Z. Is 1 divided by Z1 plus Z2 plus Z3. So now this current source with impedance is replaced by current source with admittance I and Y equal to 1 by Z. Right. So this I is calculated by using the formula. This Y is calculated by using this formula. So in this video we discuss about the Millman's theorem. Converting n number of current source or voltage source into single current source or voltage source. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.